Okay. Before discussing this capacitor filter, inductor filter, C filter, or L filter, or choke filter, or LC filter, or pi filter, I will discuss about I will discuss some basics things which are related to these topics. Now, one is resistance. What is resistance? First, I will define resistance. We can define it as like this. It is a measure of opposition to the flow of current. Current is an electrical circuit. Like the opposition to the flow of current in any electrical circuit is called resistance, and its unit is ohm, represented by this symbol ohm. Next we have reactance. Reactance. Now, reactance is basically nothing but it's the resistance offered by an inductor to the flow of current is called reactance. The resistance offered by inductor or capacitor, or inductor to the flow of current is called reactance, because once we have a capacitor on the path of flow of current, or once we have a reactor, what we call it, inductor in the path of flow of current, then both these components also provide a resistance to the flow of current. So the resistance offered to the flow of current by this capacitor or this inductor is called reactance. As we know that a capacitor is a device that stores electrical energy in the electric field, and a capacitor is basically a two-terminal device. Here we have the positive one plate, and here we have the second plate. One plate is connected to one terminal, and the next plate is connected to other terminal. So it is a two terminal devices which store electrical energy and electric field. Now, the ability of a capacitor to store energy in the form of store charge or electrical energy is called capacitance. How we define the capacitance? The ability of capacitor to store charge or electrical energy is called capacitance. Now, its unit is farad, and the symbol of its unit is farad. given after the name of well-known physicist Faraday, denoted by this F, and its symbol is this one. Whenever we have this symbol, it means this is a capacitor. Now we have capacitive reactance. Now reactance means the resistance offered by a capacitor or inductor to the flow of current is called reactance. Now we will define it specifically for the capacitor, this reactance for capacitor. So we call it capacitive reactance. Now when a capacitor is used in an electronic circuit, then this capacitor also offers opposition to the flow of current. So the opposition offered by the capacitor to the flow of current is called capacitive reactance. Denoted by this symbol Xc. And I'm not going into the derivation of its value, but I will write the direct expression for this capacitive reactance, which is equal to 1 over omega c, where omega is the angular frequency. And its value is omega is equal to 2 pi over t. And we know that frequency is equal to the reciprocal of time period. So this omega is equal to 2 pi f. So Xc, capacitive reactance, value will be 1 over 2 pi f c. If we look at this equation, then this capacitive reactance is inversely proportional to the frequency. Now for DC current, the frequency is 0 because we have the DC current, which is a constant current, so its frequency is 0. So once we put this f is equal to 0 in above equation, we have Xc, which is equal to 1 over 0, which is equal to infinity. So this is the resistance offered by the capacitor to the flow of current. So the resistance offered by this capacitor to the flow of DC current, because we have f is equal to 0 for DC current, is infinite. So we have infinite resistance to the flow of DC current. So it means that DC current cannot pass through the capacitor because the resistance offered to the flow of DC current is infinite. Now we will check it for the AC current. For AC current, frequency will be finite and non-zero. Finite and non-zero. So if frequency is finite and non-zero, then if we put a non-zero value here with finite value and non-zero, then Xc will also be finite and small, because we have 1 over this something. If we do it, we get a small value. So the resistance offered by the capacitor to the flow of AC current is finite and small. So it means that a capacitor blocked DC current and passes AC current. This is all about capacitor. So keep it in your mind, because I will not repeat this thing again and again. Keep it in your mind this, that a capacitor block AC current, DC current, and allow AC current. Why it's block DC current? Because the capacitive reactance is infinite, because the resistance offered by the capacitor to the flow of DC current is infinite. That's why it's block AC current. Next we have inductive capacitance. Inductive reactance, sorry. Reactance. Like a capacitor offered a resistance to the flow of current. Similarly, if we have an inductor in some electronic circuit, then this inductor also offered a resistance to the flow of current, which is called inductive reactance. The resistance or opposition offered by the inductor to the flow of current is called inductive reactance. Inductive reactance, and it is represented by this symbol XL. L for the inductance, and this is for the reactance, and its value, the value of XL is, I'm not going into the detail of the derivation of the formula, just read your second year physics books, might be you will find this formula. So the inductive reactance XL is equal to omega L, but we know that omega is equal to 2 pi f, so XL will be equal to 2 pi f L. This is the formula in terms of frequency, and this is the formula in terms of angular frequency. Now for DC current, for DC, frequency is 0, because we have the DC current which is constant. So its inductive reactance XL will have a value which is equal to 0. So it means that in an inductor offered 0 resistance to the flow of current, DC current. So DC current passes through inductor without any resistance. So it means that inductor allow DC current without any resistance. But the frequency of AC current is finite and non-zero. So if we put this value, finite and non-zero value, in above equation, then XL will be finite and non-zero. So it means that this inductor provides a resistance to the flow of AC current. Inductor offer resistance to the flow of AC current. So this inductor tries to block AC current. So in summary, I can write inductor will have DC current in block AC current, while capacitor will have AC current in block DC current. In the next video, I will discuss about capacitor filter or C filter. Thank you.